What's a system of equations? Well, basically, it's two equations, okay, that represent lines, okay, generally, and we're looking for where they cross, the point of intersection. Now, one way to solve these really quickly on the test is if they give you the points of intersection, you can just go ahead and plug in those points. So, for example, if one of the possibilities, the multiple choice answers was like -1, 2, you could say, well, I'm going to put -1 in for x, I'm going to put 2 in for y. If that makes that equation true, and if I put it -1 in for x here and 2 in for y, and that makes the second equation true, if it makes both the equations true, we know that's the common point of intersection, and that's our answer. So you can back substitute, and that can be a very quick and efficient way to do these types of problems. But sometimes that's not an option, so let me show you another way to solve these problems. So the first way we're going to talk about is the substitution method. So here what you have is, since y equals 2x plus 1, let's go ahead and substitute or put that in place of y in the second equation. This way we'll get everything in terms of just one variable x. So let's go ahead and do that. So we've got 3x minus 2. Instead of y, I'm putting what y equals, which is 2x plus 1, equals -6. Now I'm going to distribute the -2, so that gives us 3x minus 4x minus 2 equals -6. Combine like terms, that's -6 minus 2 equals -6. Add 2 to both sides, multiply by -1 or divide by -1, and you can see that x equals 4. Now, if we want to find out what y is, we can take x, put it back into this equation or this equation. Either one, you'll get the same answer. I'm going to go ahead and put it back in for x right here. So that's going to be 2 times 4 is 8, plus 1 is 9. So our answer is going to be 4, 9. Now again, if this was given as one of the solutions, you could go ahead and back substitute to see if it makes both equations true, and you can verify that that is the correct answer. So that's called the substitution method. The other method is called the elimination method. And what you do here is you try to add the equations together in such a manner that either the x's cancel out or the y's cancel out, right? So for this one, what I'm going to do is I'm going to multiply everything in the second equation by -2, so that this will be -2x. When I add it to +2x, the x's are going to cancel one another out. Okay, so you're with me so far? So let's go ahead and multiply everything here by -2. That gives us -2x minus 2y equals -14. I'm just going to bring that top equation down below it, okay, like so. And if we go ahead and add these together now, you can see the x's are canceling one another out, and we get -5y equals -25. Divide everything by -5, and you can see that y equals 5. Now all we have to do is take that 5, put it back in for y into either one of these equations. I'm going to put it here because it's going to be a little bit easier. And we've got x plus 5 equals 7. Subtract 5 from both sides, and you can see that x equals 2. So our final answer is going to be the coordinate 2, 5. Now sometimes on the SAT it'll say, solve for x plus y, and in which case you would just add these together. You would say 2 plus 5 is 7, and that's your answer. Or it'll just say, what's the y coordinate? And you would just list the y value. You don't have to list both points. So pay attention to the format they give it to you in. But basically you can use the substitution, elimination, or the back substitution method to solve these systems of equations. So now here's your turn to get some practice. Let's do these two problems here. Go ahead and pause the video. See if you can solve them on your own. We'll go through them together. The first one, it says, what is the value of d such that the system has no solution? Okay, so when you look at these two equations here, what does this d value have to be so that there's no solution? So go ahead and pause the video, see if you can do it on your own. We'll go through it together. Okay, so let's take a look. So we talked about the elimination here in this example. Let's take a look at elimination for this one as well. What would we have to do to, let's just say, eliminate the y values here? Well, what we could do is we can multiply the second equation by -2. That would give us -10x minus 6y equals -24, right? So now when we add these together, the first and third, like this, we're going to get d minus 10x, the 6y and -6y are going to cancel, and we get 8 plus -24, which is -16. Now, in order for there to be no solution, we want not just the y values to cancel out, but also the x variables to cancel out as well. So if d, okay, was, this is actually supposed to be dx here, but if d was 10, you're going to get 10x minus 10x equals -16, which is 0 equals -16, which doesn't make any sense. It's a nonsensical answer. And what that means is that these two lines are parallel, and that they don't intersect, they don't cross. Okay, so that's the idea here. Now another way to approach this problem is you could rewrite the equation in y equals mx plus b form. That's the slope-intercept form. And as long as the two equations have the same slope, but different y-intercepts, what that represents is they're going up at the same angle, okay, but they're crossing the y-axis at a different point. Those two lines also will not have a common point of intersection because they're parallel. So a couple different ways. One way is to use the elimination method, and if both the variables cancel out such that you get two quantities that don't equal one another, then there's no solution. Now if we would have gotten 0 equals 0 or negative 16 equals negative 16, then what that means is that they're the exact same line. Okay, one line is right on top of the other line, and they're actually crossing at an infinite number of points. Okay, let's look at example number 2. See if you can pause the video, do this one on your own. We'll go through it together. It says, if your friend has already read 150 pages and reads 20 pages an hour, and you have just started the book and you read 30 pages an hour, how long will it take you to catch up to your friend? Okay, so see if you can solve this system of equations to find out how long it's going to take for you to catch up to your friend in this particular book that you're both reading. Okay, so first thing we want to do is we want to write the equation. So let's just say that your friend, okay, is reading 20 pages let's see, 20 pages an hour, right? So 20 times the number of hours, plus they've already read 150 pages, and that's going to be the total number of pages that they've read. Now notice that this equation is very similar to the y equals mx plus b form of a line. The m is the slope or the rate, okay, and the b is the y-intercept or the initial condition, the starting amount, how many pages he's already read or she's already read, right? Now the second equation is relating to how many pages that you read, and you read 30 pages per hour. So if it's 2 hours, you will have read 60 pages, 3 hours, 90 pages. But your initial condition, your b value is 0 because you haven't started the book yet, right? Okay, so this is our system right here. We want to solve the system. I think the easiest way to do this is just to do the substitution method. So if p equals 30h, let's go ahead and put 30h in place of p. So that's 30h equals 20h plus 150. Subtract 20h from both sides, right? Because you want to get the variables on one side, numbers on the other. Divide everything by 10 to solve for 1h, and you can see it's going to be 15 hours. So in 15 hours, maybe not all in the same day, but after 15 hours of reading, you're going to catch up to where your friend is at in the book. So this is a very important concept, understanding systems of equations on the SAT. They emphasize it quite a bit in many different forms where you might have to write the equations yourself and solve the system. They may give you the equations and you have to solve the system. You might have to find a value where there's an infinite number of solutions or no solution, or it might just be like a some kind of variation of what we talked about here. So review the lesson if you need to. I'll see you in the next lesson.